This video is going to give us a full grasp about clustering, which is an unsupervised kind of machine learning techniques that is built to group unlabeled data based on their similarity to each other. So for this, we are going to be making use of the more customer data set. So let's load it in. So we say df equals to pd.read underscore csv. Then we say mol customers.csv. Then we say df.add. So we have the data. So our case study is going to be for annual income and spending score column. So we want to group this column of annual income and spending score based on their what? Similarity to each others. Okay, so we are going to extract out those two values. So we are going to say df dot, so let's do it this way, x equals to df dot ilog, select all rows, but only for column 3, which is annual income, and column 4, which is spending score, because if you check it, 0, 1, 2, 3, and 4. Then, like I said, we're extracting the values, so we say dot values. So at this point, we are good to go with the machine learning, but we can't just move ahead like that. Why? Like we said, clustering is grouping unlabeled data based on their similarities to each other. We have to know how many cluster points is suitable for this particular data set. On default, under the k-means that we are considering, the default number of cluster is 8. We cannot assume that 8 will be suitable for this particular example. So we have to figure it out. So let's do that first. So let's have an empty list, which we call WCSS. Then we'll put an empty list here. And then we'll say between the range of 10, let's see, maybe it's cluster 1, cluster 2, or 10. So we'll say for I in range of 1 and 10, they'll say kn equal to k-means number of cluster. This time is going to be I. Why? Because we are still trying to determine what is the suitable number of cluster. So we say km dot fit x. Then we'll say WCSS dot append km dot initial, which is the sum cycle square, which is the sum cycle square. Okay, so let's see what we have as the sum cycle square, WCSS. So we have this outcome. So based on this outcome, we cannot judge. Why? We are just saying the sum cycle square. We don't know if maybe it's cluster 1 or cluster 2. Then how do we determine this? We have to visualize it. Visualizing it will give us a full understanding of which cluster point we are going to use. So let's do that. So we say plt.style.use. Then we say gg dot. Say plt dot on the x-axis we plot that range of 1 and 10, 1 and 10. Then on the y-axis we have the WCSS. Then we say plt dot title. Then we'll call it the elbow method. Why do they call it the elbow method? Because the outcome is not even. So using the line plot is going to make it look like what? Having some elbow points. So based on those points, we'll be able to determine which of the number of clusters to use. So you can see for this, we have just 2 points, which is 0.3 and point what? And 0.4. No, 0.5 is in between 4 and 6, so it's 0.5. So for this, we are going to make use of 5. If you are the one working on this, you are meant to do for both points to know which one is going to be what possible. But because I've seen this kind of data before, I think 0.5 is going to be what? Suitable for it. So let's go straight to the machine learning. So we now say y means now. Then we have k means. Now the number of cluster this time is going to be 5 because we figure out the number of cluster point that we are going to use. Then we'll say prediction equals to y means dot feed predict x. So let's see what we have as this prediction outcome. So you can see we have 0, 1, 2, 3, 4. We start from 0 down to 4, which is from 1 to 5. So cluster 1 is 0. So we cannot explain to the client what this is. We know this is the prediction outcome from the k-means. So for us to get a good grasp and for the client to understand how this is being clustered, we have to pair this outcome with the main value from X. They will be able to determine, oh, this is the feature from X and this is the feature from Y that gives us what? This particular cluster. I'm talking about the annual income and the spending score. So let's do that. So plt dot scatter. I will say X. I will say prediction equals cluster 0 column 0, which is the annual income, against X prediction equals to cluster 0 but column 1, which is the spending score. Then we give it size of 100. Then we give it color. We say let this be R, which is red. Then label. We say this is cluster 1. We say this is cluster 1. So I'm going to copy this and duplicate it for the other cluster and just make the necessary changes. So cluster 2, cluster 3, cluster 4, and cluster 5. So we say cluster 2, cluster 3, cluster 4, and cluster 5. Cluster 2, cluster 3, cluster 4, and cluster 5. Then I change this color to blue B. I change this color to Y, which is yellow. I change this to green. Then I change this to cyan. So that's what we have. Then I change this to cluster 2, cluster 3, cluster 4, and cluster 5. So let's put our X label. So we say plt dot X label. Then on the X axis we have annual income. Then Y label plt dot Y label. We have the spending score. Then we have to put the legend. Without the legend, this cluster label is not going to pop out. So we say plt dot legend. Then we say location is 1,0. We want it to be outside. Then we say plt dot show. So let's execute it. So you can see we have different clusters. So let's start with cluster 1. Our cluster 1 is red. You can see based on annual income, the N low, they spend what? I. Cluster 2 is blue. The NI, they also spend I. Cluster 3 is this yellow here. The N low, or the NI rather, but they spend low. Then green, this N averagely, they also spend averagely. Then cluster 5, the N low, they spend low. So we now have a full understanding of our customers. So we know we have customers in diverse categories. Some NI spend I, some N low spend low, some even N as I, but they try to spend what? They try to manage themselves to spend what? Low. Now, like we said before we start, clustering is used to group all label data based on their what? Similarities. This is what we just achieved with this our more customer data set by grouping our data set based on annual income and what? Spending score. We see in our next video.